Hello, the Darkness344 here, and I know it has been a very long time since I've recorded a video. There's been several things that I've been wanting to just do and stuff, so I haven't really been able to record a video. And yeah, with the current situation, I probably won't be uploading that much, but yeah, I'll still upload, but I mean expect it to be at very least once a month, but it may not be that much. I might not upload that much, so sorry about that. And yes, I still have not updated the thumbnail or included the download link for that in my 50 subscriber special, which is unfortunate, but yeah, I'll do that at some point maybe, or I might not, but who knows. So today, this video, we're going to be building the display, and yes, I have already built this, but I'm going to break it and rebuild it because I know. Yes, I don't know anymore. So yeah, this is what we've done so far. We've built quite a lot of it, and yes, it's been a very long time since I've done this, so I may still be a bit patchy on some stuff. So alright, here, so I've made a list down here of the stuff that we may do or may not do in this video, and the next video after this will be the final video, and that will be programming this out, or how to program this computer, and I'll also be writing a simple Fibonacci sequence program on it, and that could be pretty cool to show off. And it's a very fast computer, by the way. I've said this probably loads already, but it's quite a fast computer, and I think it's pretty cool actually. So the things we're going to be doing, we're going to make the display, which we'll make with the decoder and everything. Make the registers, those are quite important for the display. Maybe make a binary display, so maybe underneath or on top, or maybe on the control panel over here. That could be cool, just the raw binary output, so we don't have to look at this, and it won't be linked into the display registers. It will be coming straight from this, so whatever is on the main data line, right, we'll just be able to read, we'll have a display on top of this button or something. I don't know, it will be cool anyway. So yeah, we may make a clear ALU. That's for debugging. You don't need it, but I mean, because the ALU clears each time you write to it anyway. But I mean, say you have something like this and you don't know if it's broken or not. So almost like a BIOS goes through the computer. Yeah, I really don't know what, but almost like it checks all the modules, make sure they work. If we want to check to make sure this works and say there's something broken in it and we don't know about it, we can have a clear ALU button and try read and write manually ourselves and see if it's broken or not. And the way we can reset the entire ALU is by triggering these down here, the ALU-A and ALU-B registers. And remember, we can only trigger them if there's nothing on what's this called, the ALU input from the main data line, of course. So since there's nothing on it, this button would only work if there's nothing on it, because what we can always do is break this line, so stop the signal coming from this line by putting pistons over here. But I'm not sure if that's necessary or not, because if we could have that, but we don't need it. So at the moment these are all on, but we could turn it off by, as you can see, just by putting a pulse. And the way we do that is have redstone torches underneath these linked up to a button on our control panel. So that would basically be a reset. We don't need it, but we may add it if there's enough time in this episode. I should have started the timer, but I will. So then we're going to make a program. We may make a program reset which would jump to line 0. It's not needed though, because we have this lovely line which is the program on off, and yes, there's no complete reset computer, you have to click them manually. But I mean, if we wanted to jump back to line 0, we'd literally turn it off, then turn it back on again, and that would basically do it. So what else is there? I'm trying to get a timer up at the moment. I'm not sure if I have a timer on my phone. So we're gonna make the binary display, maybe make update display registers. So it will be update display registers. It will be like a command which will go there, I think, I don't know, which whenever you click it, it updates the display registers, so they update to whatever is on the main data line. It won't be clear display registers, because that's quite useful when it would reset them to blank, but I mean we'll have an update display registers, so it's just nicer. I feel like an update one. I know this is meant to be a very simple computer, so I think just updating it would be easier. If you were to clear it, you have to make sure that there's nothing on the main data line, and then you just click clear. And yeah, so we probably won't have that. And do I have a timer on my phone? I don't actually think I do. That's unfortunate. So let's just online stopwatch. Let's go. Okay. Yeah, I just don't want this episode to drag on too long. So what we're going, yeah. Sorry, I'm kind of getting a bit distracted, aren't I? It's been a long time. So what we're going to be doing is making this display first. I've opted for a small one like this, so there's no gaps. What I mean by gaps is, let's go over here. Are these flight duration? Oh no, 3. So this has the gaps, right, and it's quite a big display and it has the gaps and stuff. That's what I mean by gaps, and it looks fairly decent and stuff. But I was thinking I'd just design this one real quick over here, and it's smaller, as you can see, so, and the computer is kind of small, so it's better. And also, since I think this is a 4-bit computer, let's just check real quick. Yeah, it's a 4-bit. So 1, 2, 4, 8, then 6 to 15, yeah. So it doesn't go over 2, so the tens column will never go over 2. So that's also why which means we don't need to have any other number than 0 or 1 on this. So that means I've rigged this up just to display 1. So we don't need separate things like that. We can just have one that automatically just turns on the number 1. And for 0, we could have a 0, but I mean, it's easier just to have it blank as 0, because, you know, same thing, basically. What was I going to say? Yes, we are using a ROM display drive, so that is basically where we have, it's a lookup, basically, a lookup command. So say we put the binary number 15 in, it's a multiplexer, I think. It basically says, oh, the number 15 has been put in, so display number 15. It's good for small numbers like this, because we only have a certain amount of combinations, so I'm trying to find one in my world at the moment. So it means, I think there's one over here, yeah. So it means, yeah, so I really can't do it. So it means that there's only a small combination, so it's simple, it's basically simple. So say I wanted like I could put this number in and it would come up with that. I could put this number in and it would come up with 0, apparently. So 1, 2, so 3. It's individual numbers, so it looks it up. So say you put it, so it would just be the opposite of this. It will be giving out your base 10 numbers here, and you'd be inputting your binary numbers. It's quite simple. I think it's like a multiplexer or even a demultiplexer. I really don't know, it's been a long time. But basically you put in your binary numbers and it outputs your decimal numbers, and it's good for small numbers because it's simple. Whereas if we were using larger numbers, so say we had an 8-bit computer, we'd want one of these, which is a binary coded decimal converter. So it converts binary into binary coded decimal. That's basically, it's separated into 4-bit numbers, so it's 1, 2, 4, 8, then 10, 20, 40, 80, 100, 200, 400, 800. And I've made a video in the past of a display that I've made for one of these. It's a display driver, so, and it's very nice, compact and small, and it goes from 0 to 99, which is very good actually for how small it is. There is a video, I'm not sure if I'll put it in the description, but I literally only have like 17 videos on my channel. It won't be too hard to find. So alright, we better start off before we run out of time. So first of all, I'm going to break this. I think it's 11 blocks, so 4, 5, 6, 7, 8, 9, 10 on the 11th one. So what we're going to do is, first of all, I'm going to break this. I should just use TNT, shouldn't I? Destroy. Alright. Alright, so first of all, we're going to find the middle of our place. So the middle is between these two blocks, because we made it an even number, because I was thinking of making one of them big displays, but that doesn't matter because we can still, I made that display down there with an even number. So this is the middle basically. So we're going to just go out 10 blocks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm saying 10 blocks because it just looks alright. And then on the 11th block is where we're going to build. So let's just break all these because these are placeholders I missed. Alright, there we go. So this is basically our middle. So below this, just one below, you can design this however you want really, but I mean, it's nice to follow this general pattern because it looks alright. Like, you can do it whatever color you want. You know what, like, you could really make your own display if you want. To be honest, I'm just making this because it's a very simple display, and it's one too low, isn't it? Right. Yeah, this is a very simple display, so it's good for starting off, and especially with this computer. This computer's all about simplicity. Like, as you can see, it only has, the only operations you can do is add numbers and subtract numbers, so like, I mean, it's very simple. Like, of course you could add more operations if you really wanted to, but I mean, if you know how to, great, do it, because it could be very useful. You could have a variety of operations. Like, my first computer that I made was absolutely massive. It was and stupidly slow. It was a 5-bit one, I think, yeah. To be honest, I've only made 2 different computers, this one and my 5-bit one. But I mean, this one's so much better than my 5-bit one, even though it has a much smaller instruction set. To be honest, if I really wanted to make a better computer, I'd make an 8-bit one with this ALU over here that I showed off in my subscriber special, 50 subscriber special, and guess what? We're now at 69 subscribers. Nice. So, anyway, yeah, if I was going to make a 8-bit one, I'd use that because it's a very good ALU. However, I probably will not build an, you know what, we're building out of this concrete. I probably will not build a 8-bit one just because it will take a very long time. So what I've done here is basically made almost this 8 pattern, right? So these top 3 need to be powered, and the way I'm going to be powering it is by having a repeater like that face into them. And as you can see, it powers those top 3 and none of them else. And the way I'm going to power the others is just do the same, like this 8 pattern. So on the bottom 3, as you can see, the bottom 3, we're going to have a block and a repeater like that, and that should be powering just those bottom 3, nothing else. And if we want to only power these side 3, we have to have a block. See, there's 5, I think, yeah, 5. You want to have a block like this, have a repeater on top of that, and that should only power those 3. So it powers the one the repeater goes into, the one on top, and the one below, which is perfect. So let's just make sure we have that on all the sides, because I've just broken them. And I know we don't need repeaters, but I mean, it just makes things look nicer and makes things simpler, so we're going to have that. Then so this is going to be our 10s column, and this is going to be our 1s column. So we're going to want to be building that down there. So actually, since this is our 10s column, we don't need any of this, because the only numbers that are going to be displayed on this are 0 and 1, and as we already agreed, 0 is just going to be blank. So 0, 0 is just blank blank, basically, or like 10 would be. 10 actually would be 1, 0, so we will have to have a 0 for that. But I mean, we won't use it that much. I'm trying to think now. So what we're going to be doing is we're going to pull off these wires and we're going to bring it down over here and just make sure. Perfect. Alright, so we can have our first. I'm not sure if that's going to hit that. We'll just do it like this. Okay, so we're going to bring that one down, bring it down again, like that. And then, yeah, we'll bring it down one more. And this will be the beginning. Then link up redstone like that. Then we're going to go run across. And actually, we're going to have to go several out, won't we, because of this top one. So we're just going to build a long line like this and break every other one like this. Whoops. And I'm not even sure if we need that. Then this one we can just, whoops. This line we can just pull out like that. We're actually going to have repeaters here. Okay, make sure you got all your redstone. So actually we don't even need this because this can go straight into this one, can't it? I've forgotten how I'm going to do this. It's going to be like this. Yeah, this should do it. And the reason why is because the only numbers that's going to be displaying on here is blank and 1. So that instead of having to do the separate bits of it, we can just do 1 as a whole number like that, because it really doesn't matter. Then this is going to have to go up to there, so we're just going to bring this up. Okay, we might have to bring it up like this. I'm not exactly, I think this might be 1 too far, I don't know. It should work still. Okay, so now this one should go up to here and into that. Now we want this one to say this one, I guess, because yeah. So just gonna bring it down like that. And then this one is gonna be a bit harder. Yeah, I think I've gone 1 too far out. We're just gonna go 1 back just to make it, just in case. It will not matter too much if we do this. So that means I'm actually gonna change this design up a bit, make it a bit more space efficient. I can't speak. And you'll probably have your own design for this, but I mean, it really doesn't matter too much how you make it, as long as it all links up properly. And since we now have space for this one, we can link it up like this. That's a problem. There we go, fixed. Yeah, and then for this one, we can just go like this. Try to get around the back. That should link up nicely. This one is straight. This segment is quite easy. Oops. And then we need these ones. So this one, and this one. Oh, that's going to be very easy. So this one we can just bring down here like this. Oh. And have a block here to block these redstone signals because you don't want them going into each other. Also have a block there as well. So, and then this one will just lead straight on into this one, like that. Quite simple. Well, actually I say simple, but I mean, it's a bit big. It'll be fine. So now what we want to do is we're just going to place levers down to test. Make sure all of them work, just in case one of them is broken or there's not enough signal length. So as you can see, they all work. Make sure none of them overlap as well. You can try that out. I mean, trying to make sure none of the repeaters get overdone. Alright, so now that we've got our basic display, we're going to actually want to make the decoder for it. And I know we should have brought this up to it first, but I mean, this is quite easy to do. So we're going to want to make long lines. So first of all, we have to figure out how many different combinations of numbers there are. So there's 0 to 15, I think, because this is a 4-bit. Yeah, 0 to 15. So that's 16 different combinations. So we're going to have to put in 16 different lines for this. I think it's, yeah, 16, yeah. Okay, I'm just bringing this out right now. Okay, we can extend this later. So we're going to want our redstone torches on this side, because that makes things just nicer, I guess. So we're going to want to make our first line here. Make sure it's not on top of this, or your redstone torches will be on these repeaters and it won't be powered. So that would be our first line. So we're going to actually extend this. We're going to have to make this longer, of course. So just because we want to put redstone in here, instead of making these lines first, we're going to have to put the redstone in here first, then make these lines. So to know how long we're going to be doing, is we're just going to make a line like this and make sure there's 16 of these, so 16 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So that is 16 of them. That is good. That is what we want. Okay, I'm going a bit senile now. Alright, so we're going to want to extend all our lines over up to these, like this. And I recommend now's the time to put in the redstone for the first line. And of course we will add repeaters later. Alright, so we're just going to have to extend all the lines like this. And now we've done that, we're just going to add the redstone, of course. Might as well add it now. And this is basically going to be the display drive, the actual driver, because that's the display, this is the display driver. So almost like the GPU, but not really, because it can't actually draw shapes, it can only display numbers. So, as I've said previously, this computer, if you've been building it in Java Edition, you will have to do changes concerning all the pistons and stuff. Maybe, I'm not too sure, because I haven't tried building this in Java Edition, and I'm probably not going to. But, yeah, you may have a few difficult problems with the pistons. But if you're building it in Java and you know enough, you'll probably be able to find ways around that. So that is good if you can. If you can't, I just try and learn ways how to do it, because most of the components using pistons are actually quite simple in this computer. I'm only using pistons to break redstone lines because, like, yeah, just to stop redstone getting through certain places. You can use other ways of doing that. There are other ways of doing that, is what I meant to say. Alright, so now that we've got all our lines in, we can put redstone on top of these as well. And what I'm going to do here is put a redstone torch here, so we can see the maximum length of this signal here. It goes right up to here. This is perfect because we don't want a repeater here, because if we have a redstone torch here, as you can see, it will be blocked. So we want to put our repeater right under one of these blocks. Oh, that's perfect. So we only need one repeater in that. Now what we're going to do is we're going to copy it for every single one of these. I missed. Okay, there we go. And then we'll just break this redstone torch. Now we're going to want to put redstone along all of these lines. Make sure every piece of redstone is there, because if you're missing one, it could break the whole thing, and that would be unfortunate. Make sure to, once this is done, make sure to test every line and stuff, just to make sure it all works, because it's really annoying if you spend a whole bunch of time on something and it just doesn't work, because you've missed a piece of redstone or missed a step in the tutorial. That is why I try and include everything on camera, because it's really annoying when, yeah, as I've said in the past, it's really annoying when someone just goes, oh, and I've done all of this off camera and you should easily be able to pick this up, where it's kind of hard to do because you don't know how to do it exactly. So yeah, now that we've done this, we've got this long line. I know it's big, we could have done this section on top of this section, made it smaller, but space doesn't really matter, I guess, because this is just for simple testing purposes. So now that we've got this, we can actually start bringing these lines up to these. But first, I want to see if we should build the display first. Just checking the timer. Make sure, alright, it's been 20 minutes. Okay. So we have, yeah, a reasonable amount of time left. I might even make this into parts, I don't exactly know, just in case it takes too long to make. So if we reach like around 40 minutes, then I'll make a part 2, because yeah, I've been uploading quite a lot of voice crack. I've been uploading stuff that kind of take a bit too long. So I'm just wondering how we're going to do this. We don't actually need to knot the... So what I'm trying to figure out here is we need the demultiplexer, I think. I really don't know what it's called. It's the multiplexer or demultiplexer. Basically, it's going to be right here along this line, and it has to feed into this. And I'm just deciding if we need to knot it or not, because these wires, their default is going to be for off, they're going to be on. That they're going to be knotted basically. So we should have these off, I think, because yeah. And then these wires are going to have to come down here. And to make things simpler, we can always just drag them out here, bring them down like that. Okay, so what we're going to do is build the thingy. Oh god. So we're going to, I'm just trying to think. Hang on, let me take a break real quick. So I've just had a look over, and I've just been thinking about how we're going to build this, and we're going to build the decoders in line with this, just for the one reason that the CPU, we still need to build the, what are they called? It's the registers, don't we? We still need to build the registers for the display, or else it won't work properly. So, of course, we're going to want to have our things in line with this. We're actually going to go up several times. I'm guessing about this height is alright. Is that the same height? Yeah, perfect. Okay, so we're going to go this height, and yes, I know we still haven't wired up the clock line, but we'll wire that up after we've done this, so we know how much space it's using. So we have to make sure these are in line with those lines over here. So this line over here has to be in line with this block. Oops. And that, yeah, in line with this block. Okay, perfect. And then we can just, yeah, bring this all the way over here. Like, I mean, we don't even need to go up this high. We can just bring it like that. So, if these are going to be like that, for 0, we're going to want these all, hang on actually, you know what, let's build these lines first, just because it's probably easier if we do that. So what we're going to want to do is go over to our main data line over here, and you see where these branch off like this. We're going to go pick this one, go up 1 like that, so we have this Y shape, go up 1 again, so we don't block that off, and we're going to extend this all the way under that wire, all the way down here to here, and we're going to do the same for all of them. So we're going to extend this one all the way down like this, like this. Actually, we could just bring this along like that. We're going to do this for all of them. Yes. Oh, what am I doing? Okay. Now we just need to do the last one, just like this. Up like that, up again. And there we go. We can add the redstone, but I mean, it's not essential. So since this is our first one, and it's going to be 0, we're going to have the repeater. You know what? We're going to need to do the repeaters, aren't we? So first of all, let's add our redstone like this. And we're going to find the line that's farthest away. So this one. We're going to 1 count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Have a repeater here. And hopefully 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, perfect. So if we power this one, it should also power that repeater. Perfect. So let's just make sure if we power all of these, they'll also hit those repeaters, just in case. Yeah, perfect. And then if, of course, if we power this one, it should power that one. Nice. Okay, so now that we've got these repeaters in line, we can just go. I'm actually going to turn this on real quick, so we don't need to count. I'm going to bring it all the way over here, so we need a repeater here. So we're going to do redstone first. And just for convenience, I'm going to bring... Yeah, I most likely will do this in 2 parts, just because... Alright, I know that'll make it'll make it a lot more confusing to find the different episodes, but I mean, I'll just do another part. I won't split this, I'll split it into 2 different parts, but I mean, it'll just be one thing if you guys see. Okay, since we're gonna have a block here, since this is where our line starts, we need a block here like this, and since this is gonna be 0, because 0 would just be both of them off, we're gonna put our torches down like this on the side, and then blocks on top of those torches, and then torches on this side. So you have, it just basically extends up. Then on top of this, we're going to have a redstone line, like that. I mean, just a line of blocks, and on top of these, we're going to have our redstone line. So it's a good idea to actually turn this last line on, so you have this redstone torch on. If this redstone torch is off, then just turn it on by a lever. Make sure this one is on, so you can see how long the signal will last. So we can actually just go down here, I guess. Yeah, that should do it, and then we'll just go across like that, and of course we'll add repeaters. So for all of them, we're going to go out this far, so you could even start building out this far if you really want. I'm just going to do it because it makes things a bit easier. So, now that we've done this, I'm just going to place the redstone on top as well. So, yeah, we'll just make sure the redstone's on top. We'll have the repeaters in after this, of course. And then, once we've done this, we're going to want to do the same thing as we have up here. Just go up one like that on every single one. But we'll do that in a minute because we want to put the rest of the lines in. So we're going to want to go all the way up to the end. Like that. And that's the end. And we're going to want to do this with all the lines. So I mean, this decoder isn't the fastest decoder in the world, but for the display it doesn't have to be fast. Like over here is a faster decoder, but that's because this needs to be almost instant for the CPU line. I mean the program counter, because that's very important. It's very important to be fast, and so this decoder is smaller, but I mean it's slower as well because we have alternating repeaters every line, so it also makes the display be a bit weird, behave a bit weird, but I mean I guess it's alright. It doesn't matter too much unless you're feeding this into something other than a display. It really doesn't matter. So what I'm just doing is placing blocks over like this, and of course to make it look better I'm going to be destroying the blocks underneath because it's all about aesthetics. Not really, but it just looks good. Right, so we're going to want to go up like this. You know what, I'm just going to go like that. Oops. And you really don't need to break these, but I mean, I think it looks better, so that's why I'm doing it. Should install some sort of reach command or mod to set the reach higher so I can hit that block. As you can see, I can't hit it from here, but I mean, should make an infinite reach. Okay, nearly there. I know you're probably just skipping through this at this point, but I mean, include everything on camera. Part of the sacrifice you have to make. Alright, so now that we've got all these blocks, we can start actually encoding it. So first of all, we want to find our lines. We can label it if we really want, but I mean, it doesn't, like, to be honest, 1. This is 1, so I mean, 1. So 0, 1, 2. I'm guessing this line is 2. Let's see. Oh, yeah, no, it's 4. No, it is 2. So this line is 2. Okay. So we're doing this backwards to this one, basically. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, which is trying to think what 15 is. There we go, all of them on. And so now that we've done this with the torches, we want to, because yeah, we just place a torch if the number's on, and as you can see we haven't placed any torches on this because it's 0. We have placed them like this though, so if the number is a 0, if the number's 1, we just place a torch on top. If the number is 0, we place a torch on the side like this. So I'm just going to do this for every single one of them. So you may have noticed a pattern, and that is true. For the ones, the 1 column, it alternates, it goes 0, 1, 0, 1, 0, 1. There's a space of 1 between. For the 2's column, there's a space of 2. For the 4's column, there's a space of 4. For the 8's column, there's a space of 8. That's quite useful if you're trying to program in, and it just makes things a lot easier. program in and make sure you've got every combination right. Because you know if you have 3 on a 2 line, you've done something wrong. Okay, now that we've done that, on every single one where we've placed a torch on the side, we're just going to put a block on top. So this does take a long time to do, but I mean, if you want a number display, it's worth it. And anyway, even if you were doing binary coded decimal, you'd have to make something like this anyway, just for it to work, so. Because you still need to display the digits 0 to 9. Alright, we're nearly done, and there we go. So now that we've done that, of course, we're going to have our lines on top like this. So you know what, I'm just going to bring this down like this for now. All the way up to here. And just break the ones in between. Or not. I cannot click properly. Seems. Why is that double breaking? Okay, never mind. We're just going to break them. I clicked once and it broke 2. Okay. Razor Death Adder Elite for you. Okay. And of course we need to bring these down like this. Oh yeah, before we do this, we should actually add the torches on this side. So, for the ones that we've just put the block on top, we're also going to have to put a torch on the block itself. Of course, these ones do not have a torch on. So I forgot to mention that, I'm sorry about that. I mean, it's quite important we have this. You know what, I'm just going to do the ones column first. So basically this signal is just brought up and these signals are knotted. You'll be able to see once this is finished why that is the case. Oops. Really? This is taking longer than expected. Okay. Yeah, now we just need ones here, don't we? Okay, I think that's about it. Make sure, I would even go to test it, just in case. So, once we've done this, in the next episode, we'll be building the registers for this first display and linking up a whole bunch of other stuff, as well as, yeah, the next episode the computer should be fully complete. So the remainder of this episode we're just going to finish off this display decoder because quite important we have it. So one thing that I haven't put in here yet is linking up these, and we'll also do that. But first we want to put in these lines on top. Okay, now that we've done this, we can put redstone on these, but before that, we're going to have to put the things in just to make sure these work. So we're going to have repeaters on this row. So since we have redstone here, we want repeaters on the next one. Since we have repeaters here, we want redstone on this one. And redstone repeaters. So it's a oscillating pattern. So redstone's here. And I'm just going to put in the redstone first because that's easier. Okay. And then repeaters on these ones, of course. And make sure they're set to the lowest possible tick. Like make sure they're set to 1 tick, or else it'll be much slower. And I mean, this display drive doesn't have to be super fast, but it's nicer the faster it is because it looks better then. Okay, I think I've nearly done all of them. And once I've done this, I'll add the redstone. Okay, I think I've done all of them. And that redstone signal should travel all the way to the end. So you've seen it. Now we're going to add the redstone on top of these. If I can make that. And once we've finished this, we'll end it here because I'm probably running out of recording time. And I think after we finish this, it's a good stopping point. Okay, so just redstone on top of these, and we'll add the repeaters in as well, just to make sure it all works. The next part will be adding in the registers, programming this, and linking up anything that's not linked up. So yeah, that should be cool. Okay, this is nearly done. It's taking a long time. Okay, now that it's all done, you can try it out, make sure it all works. At the moment, one is going in, so of course the one line is turned off, which means it's turned on. So to make sure it all works, we want this one powered. So this piece powered, so you can put a lever like this, and then go all the way to where it ends, which is here. And since you would normally put a repeater here, but that's where you can put your torch, we'll just put a repeater before that. So put repeaters all the way on every single one, just like this. Like that. And then hopefully it reaches the end. Yes, it does. So if we put a redstone torch, it'll turn off. Okay, perfect. So now this is pretty much done. The only thing we need to do is program it, which is annoying to do, but I mean, we'll have to do it. So we'll do it next episode. And I'm just happy that I could do one of these because it has been a long time. And of course we'll also add the registers here because those are quite important. So yeah, if you liked this, please like the video. If you disliked it, dislike. I really don't care, to be honest. It's just yeah, it'd be nice if you did enjoy this, and hopefully if you are building this you understand everything. If you don't, I just keep trying to learn, and don't just watch my tutorials, like watch other computer tutorials as well, just to see how they build their computers. See if you like, you could, if you are good enough, you could even add improvements to this one, because I mean this is a very simple computer. It's just for the starting out, like it only has subtract and add on the ALU. To be honest, you could add more if you wanted, like more functions. You could add more RAM. I know this RAM is kind of messy actually. Or you could add more, you could make it an 8-bit computer, you could add better display. It really doesn't matter, but I mean, yeah, I just hope you enjoy this simple tutorial, and I hope it provides some useful insight into how redstone computing works. Because it isn't all just about binary, because it's also about timings and stuff because of stupid signal length. I mean, because normal computing you don't have to worry about timings as much as you do in redstone computing. And of course redstone computing has to be simpler just because it takes so long to build something, where normal computing you have like predefined chips and stuff that you can just drag in and make. And I know it's more complex and probably harder to do, but I mean I would say this is just as hard, because you actually have to design the whole thing, make sure it all fits in the right space, because if it's large then it's going to be slow. You want it as small as possible just to make it as fast as possible. Like this is a very 2D computer. Like it's very fast, but it's still 2D, which means it's, as you can see, it's like one flat thing. It's not a small little ball. I don't know what to say. But yeah, it's still a fast computer. I mean, you could always put the RAM under this and like put these on top and like just make it simpler. But I mean, to be honest, this just makes it, this is a nice layout, just showing you where the different components are. So like your ALU, your RAM, your program counter, and your main data bus going around in this big nice loop that isn't really a loop, and your display with the driver and stuff, and your control panel of course. But yeah, this is basically just to learn stuff. So yeah, I hope you like this tutorial of building this, and yeah, next episode hopefully we'll get this done, and after that we can even program it, which could be really cool. So yeah, please like and subscribe, and I am out. get ready for the next one, if I can be bothered to record it. Yeah, I will try. Yeah, see you later. Thanks for watching, and goodbye.